As I mentioned before, please use Slido. I will be checking here the screens. And the first thing I would like you to, what I would like my panelists to do, is to introduce themselves. We have an all-women panel to start the conference, which is really good, talking about AI. And if you can introduce yourselves for our audience.
Okay.
Lucia.
Yes, I'm Lucia SPECIA. I'm a professor at Imperial College London and also Sheffield University. And my main research area is actually machine translation, but also more generally natural language processing. Anything else?
No, well, yeah. Alison?
Hi, I'm Alison Lowndes. I work for NVIDIA. I actually joined NVIDIA after returning to education. I went back to university at the grand age of 42, studying artificial intelligence. And I basically hit the ground running because that was when everything really exploded. NVIDIA has a lot to do with that. It's not just data and the existing algorithms, but it's the graphics processing units that have really rocketed and provided the compute. So I spend all day, every day, immersed in AI, and that obviously incorporates machine learning as well, but helping in applications of AI, so real life, on the ground applications of AI.
Hi there, I'm Rose Luckin. I'm a professor at University College London, so we're all UK-based. And actually, like Alison, I didn't go to university to study AI until I was a mature student, so interesting connection there. I look very much at artificial intelligence and society, in particular with respect to education, and looking at the implications of artificial intelligence for the world of work, and looking at how we can use artificial intelligence to help people be better prepared for the changes that are likely to happen due to AI and automation. And I also work very closely in London with a startup and SME community, looking at how we can help them use AI in a responsible way, shall we say, for educational gain. Thank you.
Thank you very much. So the first thing we wanted to do, all of us, there is certain hype about AI. We hear in the news that AI can either solve our lives because it will help people that don't walk, and at the same time, it's perceived as a monster that will control what we do, that it will substitute what we do. So between these extremes, I wanted to start or seeding the session by seeing what is AI, and especially after our keynote as well, what is AI really at the present day? What is the application of AI in our real lives? And what can we see in the near future? The future is something that is very changeable recently, but in the near future, what we are seeing with AI. So basically bringing AI from the top to our concrete. So I would like to start with Rose. Maybe, Rose, you can give us some definitions, so we have a very diverse audience here, so everybody can understand what we are talking about when we say AI.
Okay, I'll do my best. So there's artificial intelligence that we might consider in terms of the technologies. So that was a wonderful keynote earlier, and that was very much talking about the technology of AI, and in particular data science and machine learning. But we can also think of artificial intelligence as the study of intelligence. Because unless we understand what intelligence is, then how do we know if we've built a technology that is behaving intelligently? So artificial intelligence is really about the study of intelligence and looking at ways in which we can use technology to behave in a way that we would consider to be intelligent. And I think it's really important to recognize that difference. AI is incredibly sophisticated and incredibly useful, but it's not that sophisticated and it's not that useful.
As we say in translation.
It's nowhere near the sophistication of human intelligence. But because we now have a lot of computing power, we have a lot of computing memory, we've built really efficient, effective algorithms that can learn, and that can learn very quickly and very efficiently. And bearing in mind that learning is the holy grail of humanity, it's what makes us who we are, then we have some pretty powerful tools within our AI. But also remember that we've built our AI in our own image. We've built our artificial intelligence to do the things that we value particularly. And there are many aspects of human intelligence that AI comes nowhere near, particularly the kinds of issues around social intelligence, emotional intelligence, self-efficacy, understanding of ourselves. And one of the biggest limitations relates to context, which is very much where the keynote speaker drew our attention. When we learn, when I sit in this room, I understand something about how this room works as a social context. I look around at you, and I can see some of you are nodding and some of you are responding. And I look at my fellow panelists, and I use my understanding of the world to help me understand this context, the sorts of behaviours that are appropriate in this context. If I suddenly stood up and did a headstand, you'd probably be slightly baffled by why I would be doing that. There's no rule written down to say I can't do that, but I know, because I understand the social norms, I understand the context. Now, as educators, we know that context is actually the most important variable when it comes to the success of learning. And so our algorithms are smart, but bearing in mind how little they can deal with context, which we might call white noise, then we start to see the limitations. So yes, sophisticated, yes, smart, but not that smart and nowhere near human level. And if we start thinking about, therefore, what's in the near future, I think we have to be very careful. I do think that the fact that voice is likely to be the next mass platform has some significant issues for the translation industry. But I think we also need to bear in mind what it is that human translators and human interpreters do differently, which is very much about the contextual aspect of translation. So I hope that's gone some way to explain a bit about AI and different ways of looking at it, and maybe made people feel slightly less terrified about it and slightly more positive. But in the end, the bottom line is we are in charge. And whether it does evil is very much down to how we use it and how we allow it to be used. So finally, I'd like to draw attention to another point made by the keynote speaker about making sure everyone understands enough about AI and algorithms to keep themselves safe and to use it effectively, so that we don't end up with a very unequal society where there are the people who know what algorithms do and understand how to train algorithms, and the people that don't.
Yeah, so information is key, right?
Absolutely, and education is key.
And that I hope this forum goes in this line to explain a bit more how we use AI, for example, in translation. So maybe Lucia can explain a little bit her perspective from machine translation on a little bit more.
Yes, I'll take it from a bit of a broader perspective, because there's another panel on translation. So from the language or natural language processing in general, and yes, I mean, we do have AI in our applications, and there's a bit of a misconception that a lot of people think NLP, natural language processing, and other areas use AI, whereas in fact we are actually part of AI as a field. So people tend to see AI as this black box that you take from somewhere as a set of algorithms and whatever else, data, and you just plug in and you build some application, and so you're using AI. But actually, no, it's a much broader field. Language processing is one of the things that is part of AI. Machine learning is another thing. So you can see some of the things as tools that you can use for other parts of AI itself or other applications. But we actually developed together, so as part of a bigger field. But nothing of, I mean, a lot of the things that are happening, especially from the language perspective, they're not new. I mean, you all have known things like machine translation, but other applications such as very simple tasks like classifying texts according to topics, and that happens a lot in things that you might not even realize when you're doing a search on Google, that Google is actually grouping the results according to different topics. If it's an ambiguous term, for example, there are more sophisticated applications, such as taking a large number of documents on a similar topic and then generating a summary of that. Again, you might be reading some of the summaries already and you don't realize that they are machine generated. But a lot of this is things that have been going on for a long time, for decades. And as we all know, what changed many of the things recently, and this was mentioned before, is a combination of new or existing algorithms that got improved. Deep learning is a big word. Of course, new hardware, and big data. So these are probably the three main things. From the translation perspective, and again, you hear more about that later, but you probably all know about neural models, which are basically, they're very different models from the ones we had before, in the sense that they use some form of deep learning, which is actually not very deep, tends to be sort of shallow. Even if, not only if compared to what humans do in terms of how deep our processing would be, but even compared to other applications such as computer vision, where you actually have these networks with 150 or so layers, where each layer is doing a different type of processing and generating a different type of representation that then goes to another layer, and each step something is learned by this network. So if you have 150 of this major steps, then you could think it's learning something very sophisticated. With language, normally we do something much simpler than that. We may have a couple of layers, maybe you go as deep as having 5 or 6 layers, but we don't really understand enough about these models to even have a clear intuition on why we don't need more layers for this particular problem, for processing language and for translation in particular. But yeah, the main difference that we have compared to what you probably were a bit more familiar with, like statistical machine translation, is the use of this neural models. But one thing that is key to, and that was mentioned before, is that none of this is actually a black box. There is always a human designing these networks. So there is a certain architecture that is designed based on some intuition, which we like to think is some linguistic intuition, but it's not always the case. But there's some human intuition behind the design of these architectures. And there is a lot of engineering, and there is a lot of trial and error and experimentation, but none of these things come as a black box. You always have to have someone behind, some very clever researcher / engineer, developer, designing these things and building them such in a way that they work as well as possible. Yeah. And in terms of the future, just making a connection with what you said earlier about context. This is something that we've seen a lot in the language field, that it used to be the case, let's take translation as an example, where you would translate one sentence at a time in the systems and you would ignore where the sentences were taken from. And if they came from a document, you didn't really care. If they came from a news article that maybe had some additional information, such as metadata, who wrote the article, where it came from, whether it had some visual content, such as pictures or videos, this was all completely ignored. But this is changing. So we do have a lot of work, research work, and different approaches where first we look at the textual context. So if it's a sentence coming from a document, we would look at previous sentences, future sentences in that document. We'd also look at metadata. We'd look at, try and use, to some extent, common sense knowledge. So things like knowledge graphs, like the things you see on Google when you do a search, this little box that Google sometimes show on the right-hand side with a summary, like a table-like summary of things. So people have been trying to use that to make their models better. And also images and any other visual information that you might have. So we're already trying to move in that direction. But of course, it's all very baby steps, and it's all very preliminary at the moment.
Thank you, Lucia. So there are some questions in the Slido, but I'm going to ask Alison first to give us her input on her application of AI to the job you are doing now.
Okay, so I wanted to start just by saying that AI does get a really bad rep, but that's because of really cool movies. And just to make sure that everybody realizes that they are just movies, but the interesting thing is what starts as science fiction ultimately always becomes fiction. But we are way, way, way from things like transcendence, human-level AI. We are, at the moment, very, very good at data-driven AI, and that's certain flavors of deep learning called supervised learning, where you need to label the actual data. For example, we've heard a lot in the news about Facebook, and something that they did very, very recently was release a huge, huge data set that is actually helping something called the XNLI data set. And this is, there's other initiatives as well that are basically bringing 10 to 20 billion token data sets to help in this supervised learning aspect. But it really does come down to the data. I tend to spend a lot of my time now in the sort of really far outside, which is where the gaming environments come in. And this is something called reinforcement learning, which is basically just trial and error. It's not really that relevant at the moment for voice, for natural language processing, which converts to natural language understanding. But we will get there the more and more that we bring voice into it. The difference that Europe and UK and America have to the rest of the world is that we have very, very strict data laws, and so be it. The big players like China don't have this, so they don't have those limits. And you'll see them sort of edging further and further ahead because of that. That's in the data-driven world. And we're very, very good at it. We are at superhuman capability in the data-driven set. And it's basically the whole reason that we do this. And one of the questions is, should we be able to code? At the very bottom level, it's mathematical, purely. Above that, it's mathematics in the form of code. But you don't even need to get into that because the coders will put together things called UIs, user interfaces, where you literally, we now have tools across many, many companies, something called AutoML, where they're actually using neural networks, which is the basis of deep learning, to create the most optimal AI itself. So it's AI creating AI, and you really don't even need to get down into the code or even down into the mathematics, because we're creating user interfaces, and that is ultimately to make your jobs easier. There will be transitions of roles, but it's basically making everything that we're doing in AI is to make your job easier, your life easier. Think about how life was before the mobile phone. It's basically things are a lot easier for us now, even despite the traffic here. I could find my way here instantly. But I think that's really important to say that. You don't necessarily, if you want to learn how to code, go ahead. I didn't even bother to do that until my 40s. It's not honestly rocket science, but if you really want to deep down understand what's behind it, then you need to go back into or go into academia. However, in the translation industry, it's really going to be tools that we'll provide, and AI will be at the back end of it. Whether that's deep learning or traditional machine learning algorithms that are running it.
Okay, so let me, I have some questions, but let me go to Slido because I see quite an activity from the floor. Thank you very much. So I see here that Monica Broca is asking, should we be able, oh, this is what you were answering, should we be able to code? So I hope you are happy with your question. I have more questions and then I'll go to you at the end. It keeps moving. So, Professor Rose, in your study, how to identify and deliver the information most useful to the teachers when we use the AI assistants in the classroom?
That's such a good question because it hits to the nub of the issue here, and that is the relationship between human intelligence and artificial intelligence. Because in order for a teacher to be able to use artificial intelligence effectively in the classroom, they need to understand a certain amount about what artificial intelligence is. And I agree completely, it's not about the code. It's absolutely not about the code. But you do need to understand why data is important to data-driven AI. Data's crude. People say data's oil, but just like oil, it's crude. And until it's processed and interpreted, it's useless. So you need to know how that AI is using data, how it's being trained, as Alison was saying, and what training means in order to be able to use AI effectively in the classroom. I think one of the biggest skills people will need across the world is to know how to train an AI moving forward. I think that will be something incredibly important. I think people will need to understand data. As a teacher, the richest possibility with AI is actually to be able to find out a lot more about your students because of all the data that we can collect about their progress, because we can analyse their progress in a very, very detailed and fine-grained way. But in order for educators to be able to use that, they need to understand data and they need to understand how it's been processed. And then they need to help their students understand what that data is telling them about their progress and how they might learn more successfully. So it really is about looking at the relationship between human and artificial intelligence. Just because something's possible technically does not mean that that will work in society.
Yeah, and it's interesting, this thing about teaching how to use data, because maybe it's not that it's too late for us, but newer generations, right, also need to know what is their data, what the
Absolutely.
data they are giving and all that.
And why it's useful.
Exactly. Yeah.
And also to recognise that data is not without value. Every piece of data that is collected, a decision has been made to collect that data, and that decision puts that data in a context. And it's really important to recognise
and maybe
that it's not an abstract decision that a piece of data is being collected.
And maybe that's in line with some of the questions and what I had. Why is AI possible now, right? So this is related to the data. Everyone is talking about data. So why is AI possible now? And what are some of the one of the questions that in the slide that is very interesting. What are your biggest challenges that you are facing right now in your jobs? What is coming ahead in AI as well? So why is it possible now, and what is coming ahead? Lucia, do you want to start?
Yeah, I can start with my biggest challenge, which is to find enough GPUs to run my code.
Well, that's a good point. That's a good point.
No, that's. I mean, jokes apart, that is true, but it's not the main challenge. So, did you start with why is it possible now?
Yeah.
I mean, I think we've sort of covered it. It's a combination of various things, but yeah, I would say, from my perspective as a researcher, definitely hardware, which made it possible for us to run algorithms, some of which already existed, had been created in the 80s, in the 90s, but they were mostly at a conceptual level because we just didn't have the computational power to even simulate that with, and especially with a large enough amount of data that they would allow us to learn something meaningful. But in terms of the basic models from the language perspective. Things already existed for quite a while. Of course, they improved a lot. There's a lot of new things coming out every single day, but a lot of things already existed. The foundation was already there. For example, the first paper to mention neural models for machine translation was published in '97. And then nobody, of course, managed to implement it properly. And then now, 2 decades later, we actually started implementing that and then further improving it. And I think Alison can cover the hardware a lot better than I do, but really the catch there is that at some point, someone realized, maybe NVIDIA, that you could use GPUs, which are designed for gaming, to do other things, deep learning being one of them, and that's because they were optimized for handling, processing very large matrices, doing operations over large matrices, multiplication, and so on, which are also necessary for deep learning. They are the core of deep learning, which are very expressive, very powerful mathematical models that use a lot of algebra operations. And so hardware algorithms and, of course, data, like we said. Do you have anything to add on the hardware side?
Yeah, apart from the fact that obviously I'm going to sound very, very biased, but it really was this convergence of the existing knowledge, and that's, AI was first coined in 1956 at something called the Dartmouth Conference. It was a group of mathematicians, Claude Shannon, Marvin
All
Minsky.
male.
Sorry, all male. But they also thought that they could crack AI that summer as well.
Yeah,
but we're still working on that. But it was very much still in existence. Since the 50s. This is really, really incredible. And there's actually been 2 AI, what we call winters, since then, simply because people couldn't get the insight because we didn't have the data. Now we have, masses of social media. We have Google that has, all of the information on the internet that you could possibly ever need. Every kind of translation capability, for word as opposed to spoken, is there online. But then the GPU came in, and to be honest, it wasn't actually the introduction of the GPU, which was 1999. It was when we developed the language to code to program the GPU in 2006. And that, at that point, people could use them for general mathematics problems. Whatever we can digitize today, you basically convert into a mathematic representation. Deep learning's a buzzword. It should really be called representation learning, because you're just converting it into a digital representation or a mathematical representation and computing on it. As Lucia said, it is pretty much just matrix multiplication. That's exactly what the GPU was made for. But I did want to just get back to that sort of training side as well, because it was with CUDA. We've spent a lot of time, and this is really community driven. The most unprecedented thing about AI is everybody open sources the information. Everybody shares the code that they're using. So this is why we're seeing such a massive, unprecedented, progress in AI. Papers are published. I think the latest I heard was like 80 papers a day are published on the archive website. So everybody just shares, and that really allows humans to, crowdsource that, our own intelligence. But you do have to provide training for it. And we've spent a lot of time developing the CUDA ecosystem, and that includes training. There's very simple online classes. If you want to understand exactly what it means to take a data set, run it through a pipeline for machine translation or for speech synthesis, you can just spend 40 minutes doing it, and you can use our GPUs in the cloud. Basically you can use your own laptop and just log in. We basically cover the costs on cloud provision. Cloud provision is a lot, for the that has a big factor and impact on the progress that we're making as well, because you can either have a GPU, next to your desktop, or you can just burst out into cloud provision services to actually do the training side of it. So that makes a big deal. I won't get into the difference between the two, but
yeah, maybe to bring it back to a bit the translation world. You talk about a lot of data. You talk about augmenting the human with this data, with this a lot of hardware. But how is this affecting the translation? How is this augmenting translation? How is this going to affect translators?
Just one quick answer, because I think, and I will answer your question as well.
Sure.
But actually, I don't think everybody does make their code public. I think if we look at China, there's no transparency in sharing source code there.
Yeah.
So we have to be very careful not to suggest that everything is totally transparent, because it isn't. And people need to understand that. Alex, wherever you are, disagrees with me about data not being unencumbered by value.
There are too many questions.
Just the decision to collect data adds value to it. Somebody has made a decision that data should be collected, therefore it has value. Coming back to augmenting, that is a really interesting question. Now, there's a question here from Joanna Walker, which is relevant to that issue of augmenting. Yeah. As a translator, I apply my knowledge and intuition alone in my workspace. Is machine translation a way to work in a community of others, inputting their knowledge? Now, that's really interesting, because that's a very nice example of how it could augment the performance for translators, because it's looking at the possibilities that machine translation brings to interact socially with others, to maybe crowdsource understandings, intuitions, translation techniques. So I think that is the way forward. At some level, yes, of course, the fact that we can build very smart, increasingly contextualized, but in a small way, translation system means that there will be elements of the translator's job that can be done by a machine. But that means that the process can become more sophisticated, more collaborative, can expand to do different things. And that's where the augmentation comes in. But I think in order to achieve that, people have to understand enough about AI to work with it effectively. One of the nicest analogies I've heard recently was from somebody called Howard Gardner, who's now emeritus professor, but he's written a lot about intelligence, and one of his books is called 5 Minds for the Future, and one of his 5 minds is the synthesizing mind. The synthesizing mind that can combine information from multiple sources across disciplines, but also across people, and now increasingly across AIs and human intelligences. So to synthesize, to reach more advanced understandings, I think is the way that augmentation is likely to happen. But in order for us to do that, we need to understand enough about the people we're synthesizing with and collaborating with, and about the AIs, that we can interact effectively.
Somebody is asking here a very fair point. I think it's EW. Am I the only one who knows nothing about AI and machine learning? How do I educate myself? Some terms used today are unclear to me, and that is our fault that we are not making it clear to anybody there. But this is a problem, right? How do I educate myself? Because we are talking about getting information and learning, but to me, that I don't code, I don't know about algorithms, I am a translator or an interpreter at home. What do I do with AI? How do I inform myself? What do you suggest?
Yeah, I was going to make...
sorry, go ahead.
No problem.
I was going to make a point about what you're saying, Rose, that we need to know enough about AI, but from what perspective? Like as a user of AI, there's only certain things I need to know, and if you're using certain technology, I guess to me what that means is that you should learn what to expect from the technology, not necessarily how it works precisely, because that's not the point, and how it was built, but that it will have some limitations, and this may mean that it will produce certain types of errors, and especially with translations. You probably all heard that NeuroMT is very fluent, but produces certain errors that are sometimes hard to spot because they are like one word and in between a bunch of other words that are correct. So I think this level of understanding of the types of issues that you may encounter with the technology and the awareness that, of course, it's not perfect and it has limitations. And the more you know about the sort of underlying technology behind it, for example, that is built from examples of translations, if you know a little bit about what kinds of examples, is it from the same domain of the text that you're translating, or is it different domain? Is it a general? And it could be very simple. Like if you're using Google Translate, you will know that it's built from general domain text. So if you're translating some very specific domain, then you're unlikely to find the words that you need there. So I think it's this level of understanding and sort of acceptance of the limitations of the technology that we should have.
But for EW, basically AI, what we are doing is that we are using mathematical computations to understand the world, to understand data, and be able to reproduce it somehow automatically in some cases, or to identify other data. So that's basically the principle, right, for our audience if they say, what do you mean AI?
Humans are always going to be in the loop, especially in this industry. We're not suddenly going to become, extinct, and we're getting into the movie stuff, robots take over, blah, blah, blah. We're always going to be in the loop here with speech because of what's been said earlier by the context. There are so many just succinct nuances that it's going to take, and we are nowhere near the capability. AI is nowhere near the capability of understanding, those tiny nuances in speech. But to get back to the education side, we have classes. I could spend an entire hour talking to you about code and AI, but you simply will not get what I mean until you just play in the area. And we have hands-on coding sessions. You can actually just go online and spend some time if you want to learn deep down into that. But honestly, I think in this environment, in translation itself, it'll just be tools. It'll be user interfaces that you will have on your whatever the tools are that you use, whether it's computing or whether you're literally just using voice recorders and notes and paper. It'll be a tool that is based on AI that you don't necessarily have to know anything about apart from how to use that tool, because it does X, Y, and Z for you and allows you to do other things much more optimally. It's all about just optimizing ourselves, making things easier.
But I think in terms of modern AI, it is important to understand that it's about learning. I agree with what Alison said. You don't need to know about the code. You don't need to know about the specific technology idiosyncrasies unless you want to. But it is about understanding that we have systems that can learn. And in the same way as my grandson is learning to write, and he tries again and again and again, and gradually he forms the letters correctly, he understands what they mean, he's being trained. I don't like to think of it that way, but he is receiving data about whether the letter he's written is correct or not, it's confirming or not. That is what's happening with machines. Putting it simply, that's what's happening. We are exposing machines to lots of information that allows them to learn about specific things, about translation, about language. And therefore, in the same way as if my grandson is given a particularly biased set of feedback about the letters that he's forming, or he is trained using a cursive set of letters rather than a non-cursive set of letters, that will impact on how he learns. So I think seeing it in that way might make it more straightforward, because then you start to understand the importance of the data that is put in, if you like, to the algorithm, and the way that the algorithm processes that data, and the way that that algorithm is led to believe that what they are putting out is correct or not correct. Does it match? I always think about matching. When I go to the passport gate, hopefully if it's working correctly, and I put my passport in the passport gate, it looks at my photograph and does pattern matching, basically. It looks at me standing in front of the camera, it looks at my passport, and do these things match? And that's how machines learn. Constantly matching. Is my output mapping onto what I think it should be? And so thinking in terms of learning, thinking about how we learn at some level and understanding the importance of data and training, I think is as far as people need to go unless they really want to get into the technology. And then, as Alison says, it's about learning how to use the tools and the interfaces that will be designed for users to use.
Thank you, Rose. And I haven't forgotten about you. You had a question. I wanted to get this rolling. Tell us.
Yes, thank you very much. So the question is, how important is human factor when it goes about AI investigation performance? So especially when it goes about big data investigation. And is it possible to eliminate the manipulation and subjectivity in this? Thank you.
Is this for anybody in particular? For any of the speakers in particular?
Maybe, yes, Professor Rose Lockin. Yes, please.
Okay.
I thought it was more you, but yeah, I'll give it a go. I think we need to remember that as humans, we're biased as well. And that's important to recognise. And often we don't realise how biased we are. And we don't even realise when we're doing things that we're doing it in a biased way. I think it's important to recognise that the decisions that as humans we make about how we train our algorithms can lead to bias, and that there can be invisible bias within the data that we haven't yet predicted. I think this is where it gets problematic. I thought it was very interesting in the keynote, this difference between prediction and now we're moving to prescription. So we're predicting what might happen, and if we do that on a non-representative data set, and we've built an algorithm that's biased to process that data in a particular way, then we get a non-biased view of what's going to happen in the future. And then if we use that to prescribe something that should happen, we've got another layer of possibility in the way that we prescribe what should happen as a result of what we've predicted. So if we're kind of wrong right at base camp, because we kind of just make the situation worse, which is why it's important to look right at the start of where the problems might occur. I'm sure, Alison, you have a more nuanced point to add to that.
I guess I was just going to talk about the sort of manipulation side, but I could actually hopefully bring it back to this really great question from an interested participant.
Yes, it's a brilliant one.
About the reverse engineering human consciousness. So there's actually two facets to working in AI. One is a very, very computationally intensive training, especially with supervised learning, where you need loads and loads of data, which is a lot of what's happening in machine translation. You know, you have to tokenize, you have to do loads of work prior to actually feeding it in. Once you actually have a trained system, this is literally just a set of weights, of numbers, you know, and it can be very, very small, which is how you can then put it onto a mobile phone, or you could have an in-car system where you're giving the car commands. You know, you're saying switch to phone, dial, blah, blah, blah. You know, these kind of voice commands, any kind of voice application. You're then getting into the realm of what we call inference. Humans are just walking, talking inference machines. Every single thing that we do right now is about inference, is we are predicting what is about to happen. And we're able to do this extremely well. And if you think about the manipulation side, yes, bias does come into it, but really it comes down to that is exactly it. You are waiting for me to see exactly what word I'm going to say next. And an inference is the deployment side of AI. This is what I mean by the tools. You know, think of your voice application. But to get back to the reverse engineering side, we are learning so much about ourselves just by going through this curve, this learning curve of developing artificial intelligence. So to take the application that you're in of translation, you are going to learn more about what makes it difficult, what makes it easy, what's even possibly not even needed any longer to do the job that you actually do. And you will learn a stack about it. And this is a really cool thing, I think. And that's, if think of that applied to every single facet of life right now. And AI really, you know, it's not going to be an industry, it's going to be a part of every industry, including your own. So we're just going to learn more, we're going to get better, and life will become a lot easier. So I guess I'm an idealist when it comes to it. I wouldn't be in this job for any other reason. But
there was somebody that asked, is AI will make us lazy?
yeah, I just looked at that.
So
It's a
that's a
huge
great
possibility. No, I often do a talk called Who Moved My Intelligence? And thinking about moving my intelligence as being, we could offload our intelligence to machines, or we can see the current challenge as being one where we move our intelligence to be more sophisticated. And I think there is a decision to be made. There is a risk that it will make us lazy. I think that is a real risk, because I think, you know, if we're presented with machines that can do things that maybe we don't like doing, or that, you know, we particularly don't want to do, we need to think about whether we really do want to offload that intelligent behaviour to machines. Is it going to help us to be more intelligent, or is it dumbing us down?
Before we do that, as translators, and I would like you to comment, because there is a lot of talk about a lot of translation jobs being lost because of AI, because there will be certain repetitive tasks that the machine will be able to do. And I myself am amazed at the improvements of MT in the last 10 years, at incredible speed to my little corner. So do you think research should really be concerned about these job losses? Should research say at some point, okay, let's not go there, because if we go there, a lot of people are going to lose their jobs. So what is your view on that, Lucia?
I think there will be there'll be more, but at least two groups of researchers, and they should both exist. There will be the group of researchers who doesn't really care about that, and is just trying to improve technology and evolve as a society. And there will be another group of researchers who will be trying to see how that fits into society and what impact that has, and what to do with people who will then maybe have to learn new skills or change slightly or change completely their job. And I think they're both very valuable. But if we coming from the maybe first group of people, if we stop ourselves from trying to build better things because of that, then progress is at risk.
Is that progress? All these casualties? What will happen with that?
I wouldn't call them casualties. I mean, we adapt as humans. We're very good at that. We just need to find what is the new challenge within that job, or in a different job that has similar set of skills. I think people are probably tired of hearing that, but I don't think that anyone likes to be doing repetitive tasks anyway. So, and yeah, if the technology improves in such a way that we can now translate literature, I don't think this is going to be the case, but if this is the case, is there no other material that needs to be translated that's even harder, or maybe types of literature, poetry, and so on? So I think it's a matter of finding where that very important set of skills is really necessary, and I don't think we are at the point, or will be anytime in the near or long-term future, that there isn't such a type of text or material that you will need human translators for. So I think it's just finding that sort of
niche.
The niche, and the niche is not necessarily small, and we know that there's a lot of not only literature but media content, and the demand for that is increasing, and there basically aren't enough people to do it as fast as necessary. So you do need some support, let's call it that way. But I think we adapt, and we've been showing that this is the case. There's been so many revolutions before, so I don't think this would be different.
Okay.
I totally am for progress, and keeping on going. I mean, just take it down to basic biology, evolution is survival of the fittest. You know, if this is the way things are going and there's a little bit of retraining needed, take the retraining. People hate change. I know that. I've seen it up close and personal. But when you make the change, it is always for the better. Always. Life will be so much easier. But in this context, take things like transcription services. You know, there are companies now that use AI. They will take the video of us talking right now and they will transcribe it so that you can read the text. We are always going to need somebody to look through that. Or even if there isn't anybody and it's pure AI, read through that and you'll understand what I mean by incorrectly getting the nuances of how we talk and how we communicate. We're always going to need, you know, I reiterate this time and time again, human in the loop. Most AI now has to have human in the loop. You know, take the self-driving car, for example. You know, there's so much hype about it, but it's going to be a long, long time before we can literally take the driver out completely.
I think it really, I agree, and I think it is about reconceptualizing what the job of the translator is. Because why would that be static? You know, lots of things are happening. We're expecting everybody to learn throughout their lives. The implications of that for maybe needing, you know, more sophisticated translation of different kinds of material. I think it's just that the things will change. I don't think it is necessarily that there will be these huge job losses unless people are not willing to look at things slightly differently, to have a mindset that embraces that training and constantly developing professionally are going to be expected. And I think as long as people are encouraged to have that mindset and encouraged to do training, to look at how they can change what they do to make best use of what AI can offer, then actually it could be incredibly enjoyable and could lead to much more sophisticated understanding of languages, much more sophisticated interpretations. You know, if we have, as Alison's great example demonstrates, you know, we can have an AI that can translate the words that we say. Well, how about the human looks at our body language, looks at our expressions, looks, you know, there's so much more to interpreting than just, as you all know. So I think it's about change and embracing change.
So I'm going to, with these optimistic notes from our speakers, we are going to wrap up the panel. We started a bit late, so I think the coffee break is going to be a bit shorter. So we should be back here. Let me look at my information. By 11:15. So you have 15 minutes. If you had a question,